Abdullah, Arshia, okay. So Arshia, you were there in the class, right? Yeah.
Yes, ma'am.
Okay, okay. So up till that formula we have done. Now the sixth topic I can say, which is there in this chapter, is actually a theorem which you have to remember. Okay, based on that formula, first of all, there can be a second type of question, right? Which will be of this kind. Write down that given that HCF of these two numbers, that is 306 and 657, right, is equal to 9. Find LCM 306 and 659. That means same numbers. The HCF is given, you have to find LCM, right? So this is based on the same formula. Now, how will you write it? So we know that HCF of some numbers, that is A and B, right? Multiply by LCM of the same numbers A and B is equal to product of these two numbers. Is it clear?
Yes, ma'am.
Yes. Now we have to find LCM, right? So we will keep LCM on this side and we will do A into B and divided by HCF. Understood? Okay. So now that means LCM of these two numbers, that is 306 and 657, will be equal to the product of these two numbers, that is 306 multiplied by 657 and then divided by HCF of these two numbers. First, you can write HCF of 306 and 657. Clear? Okay. Now this is 306 multiplied by 657 and divided by HCF value is already given, that is 9. Now you just simplify this thing. Okay. So I can see this, we can reduce by 3. So 3 into 3 and this one 3 into 2 is 6. Then 3 into 1 is 3 and 27. So 3 into 9 is 27. Again, I can use 3. So 3 into 1, 3 into 7 is 21. 3 into 3 is 9, right? So now you just multiply 306 into 73. Tell me what is the answer?
Ma'am,
Yes.
22338.
22338. Is everybody getting this answer?
Yeah.
Okay. So I don't know what is the answer. You please check, right? Fine, Arshia, is that okay? Okay, now one more question I'm giving you. Please write down. Same type. The LCM, write down the question. The LCM and HCF of two numbers are 180 and 6 respectively. If one of the number is 30, find the other number. Now quickly tell me what is the other number. Abdullah, are you there in the class?
Yes, ma'am.
Okay, please do it.
Ma'am,
Yes.
ma'am, for the other number, we have to take it x, right?
You can assume two numbers. Let the two numbers are A and B, right? Then
Yeah.
LCM of A and B is given and HCF of A and B is given. Now one of the number is 30. So A is 30 or B is 30. So you have to find the other one. Or you can take it X, no problem. Better take A and B and then put some A is equal to 30, like that you can do. Yeah, same formula you have to use. Arshia, what is the answer? Martin.
Yes, ma'am.
Yeah, are you able to do, Martin?
Yeah.
Yes, Arshia, say something. Yes, I can see your raised hand, Arshia. Please unmute yourself.
Is it 120?
120? Yeah, is everybody getting 120?
I'm just one
Yes.
minute.
I don't know answer. Please check. Abdullah, what is the answer? Come on. Such an easy question this is. Simply use this formula, right? Simply this one. This is given, right? This is given. One of the number is given. You just find the other number.
I'm 36.
Good. Two great answers. I'm getting 120 and 36. Now which is correct? Who will tell me? Abdullah, unmute yourself quickly.
Yes, ma'am.
What is your answer? Okay, tell me the form. Tell me how. Abdullah, quickly tell me. Based on this formula. For example, I want to find B, right? So how much is B equal to from here? Arshia, please, okay, type your answer if you're not able to unmute yourself. This is not the way to sit in the class. How would I know you people are doing or not doing anything? Abdullah, talk to me now. Please unmute yourself.
Yes, ma'am.
Why do you mute yourself all the time? Please keep yourself unmute. Everybody unmute yourself quickly. Yes, Martin, you also.
Okay.
Half of my time goes in the class asking you to unmute yourself. All of you. Now, okay, see, is it such a tough question? Now, for example, let the two numbers are A and B, okay? Right. So HCF of these two numbers is already given. So LCM is 180 and HCF is 6, right? And
Yeah.
LCM of A and B is already given, that is 180. Okay. And again, A, let's say A is equal to 30 because one of the number is 30, he's saying. So let A is equal to 30, right? So according to formula, HCF multiplied by LCM is equal to A into B, right? So B will be equal to HCF multiplied by LCM and divided by A, which is equal to B. Just put everything here and find B, okay? HCF is 6, LCM is 180, and the number is 30 is equal to B. Is it is it that tough?
Ma'am, from this I am getting 36.
Okay. Then 3 into 1, 3 into 2, and 18 into 2 is 36. So 36 is equal to B. That's the right answer. Okay, Martin? Okay.
Ma'am, your voice is kind
Now
of
next type of question. Yeah, actually there is some network issue on my side today. Are you able to understand what I'm saying?
Yeah.
Okay. Okay, next type of question, which I can say, third type, based on the same formula, can be like this. Find the smallest number which is divisible by both 306, right, and 657. Okay, just note down, let's say like this is one type of question, right? And the second type of question can be this, that find the largest. I'll solve both. Find the largest positive integer that will divide these two numbers, 1251 and 9377. And okay, let's take 15628. Leaving remainder 1, 2, 3 respectively. Please note down, then we will solve both of them.
Ma'am, Archie is saying that check the chat box.
Okay. Oh, I'm not getting any chat. Arshia, send me on WhatsApp if you are saying something. Here, I'm not receiving any chat. Yeah, now I have got. Answer is 22338. No, Arshia, not 22338. Did you check this one? Answer was 36, okay?
No, ma'am, this answer is that one, like the type given that CF306.
Okay, okay. Okay, so now try to understand first of all what we have to do. Like find the smallest number which is divisible by both. Okay, so when they ask you a smallest number, then in that case you actually have to find the LCM, right? Now what is the full form of LCM? It is the least common multiple. Understood? That is LCM, least common multiple. So it is actually a common multiple of both the number. So that means 306 into something will also be LCM, and 657 into something will also be the same number, which is your LCM, which is your LCM. Understood? So it is actually multiple of both the numbers. So that is why we call it common multiple. And it is the smallest, least means smallest multiple. There can be other multiples also. For example, I can say 6, right? Now 6 is a common multiple of, basically 6 is LCM of 2 and 3, right? If you take LCM of 2 and 3,
Yes,
you get
ma'am.
6. So that means 2 into 3 is 6. Then 3 into 2 is also 6. So this is the least common multiple. Like below 6, how many numbers do I have? I have 5, 4, 3, 2, 1. So 5 is not a common multiple of 2 and 3, right? 4 is not a common multiple. It is a multiple of 2, but not of 3. Similarly, 3 is a multiple of 3, but not of 2. So there is no common multiple. So if I go 1, 2, 3, 4, 5, so the first number which is common, that means it is divisible by both 2 and 3 is 6. So least number is 6. There can be other also, for example, 12, right? It is divisible by both. There can be 18 divisible by both 2 and 3, but the smallest one is 6. So that is why it is called the LCM. Understood?
Yes, ma'am.
Okay. So in this case, when you have to find the smallest number, that means you have to find the LCM. So now you can find LCM. I'm not finding it, right? Answer is actually LCM of 306 and 657. So you will do prime factorization and you will find LCM. Got it?
Yes, ma'am.
Okay. Now come to second type of question. Now he's
Ma'am, the
saying
same method.
prime factorization, right? You do 306 prime factors.
Yeah.
Okay, and write that power of, let's say, 2 to the power something into 3 to the power something, like that. Then as I told you that LCM is equal to greatest power, greatest common powers you have to take, as we did in the last class.
Yes, ma'am.
Yeah, so that way you can find. Go back to your notes and check it out. Okay, now find the largest positive integer. First of all, you have to find the largest number, okay? That will divide. That will divide means the number is actually a factor, okay? You are dividing from that number. So that number is actually a factor, okay? That will divide this, this, this. So that means you have to find HCF first of all. HCF is highest common factor. Understood? Got it? HCF is
Yes, ma'am.
Yes,
highest.
ma'am.
So it is that number. For example, I have 3 numbers, A, B, or 2 numbers, A and B. So the HCF A will also divide A, HCF will also divide B. So that means it is a common factor of both. Understood? And it is
Yes,
the
ma'am.
Yes, ma'am.
it is the highest. LCM is the least multiple and HCF is the highest factor. Okay. Now there is something additional in this question. That leaving remainder this. So first of all, basically you have to find the exact number. So if 1251 minus the remainder is 1 in this case, right? So the number which is divisible is actually 1250. Understood? Got it?
Yes, ma'am.
Similarly, in this
Ma'am.
case, 937, in this case, the remainder is 2. So the number which is exactly divisible will be 1250. And similarly, 15628 minus remainder is 3. So the exact number is 15625, which is actually divisible by the HCF. So basically these are the 3 numbers, right? So the answer is you have to find HCF of these 3 numbers: 1250, 9375, and 15625. So I'm not doing it. You will use prime factorization method and you will find it. Okay.
Yes, ma'am. Ma'am, the this question, smallest number, it is same as the one you gave before this, right? Like the one given, the HCF 306657 is equals to 9.
Okay. So LCM, you got how much was the LCM in
Ma'am,
this
the
case?
same answer. I got same answer, 22338. But we got here.
Yeah. So, okay. Obviously, you will get the same answer if this is the LCM, right?
Yes, ma'am.
Okay. So I'm just saying that you should understand the language of the question. That is why I kept the numbers same, because you have already done this calculation before, right? You have
Yes,
actually
ma'am.
found the LCM of these two numbers. So I've taken the same numbers, but I just wanted to explain you the concept here, right? Okay.
Yes, ma'am.
Similarly, you can do this later on. Now, at least the rational number part is over. The revision is over. Now come to irrational numbers, okay? That is important for your syllabus.
Ma'am, just 1 minute.
Hmm.
Done, ma'am.
Okay. Now, seventh topic we can say is in this chapter is proving irrationality of numbers. And one of the question will come from here 100% in the exam. Obviously from other parts also it will come, but because very few questions are there from this topic, so you can prepare it well. So you have to prove that whether a number is irrational or rational. So let us learn how to prove. First is prove that under root 2 is an irrational number, right? Okay. First of all, as I told in the last class, let us revise the term. What is co-prime? Yeah, what is co-prime? What, let's say two numbers A and B, they are co-primes. What does it mean?
They will be divisible by 1.
Yeah, so there is
And
no common factor between them apart from
yeah.
one, right? This term is important for this proof. Fine, Arshia? Abdullah? Martin, okay?
Yes, ma'am.
Yeah, so co-prime you should know. Let's say two numbers A and B, if they are co-prime, so that is there is no factor between them, right? There is no common factor apart from one. Please write if you have not written co-primes. So if A and B are co-primes, then that is there is no common factor apart from one. That is the definition, right? So I'm
Yes, ma'am.
erasing it. Right. Now we have to prove that it is irrational, right? So we will do the method of contradiction. So first of all, we will assume that under root 2 is rational, and in the end there will be a contradiction, so that we can say that our assumption was wrong and it is irrational. Okay. That is called method of contradiction. So let us assume let under root 2 is rational. Okay. Okay.
Okay.
Yeah. Now any number which is rational, that means it can be expressed in the form of P by Q. Understood?
Yes, ma'am.
Yes, ma'am.
Abdullah, no, I cannot hear you. Now please stop and try to understand what I'm saying. Any number which is rational, it should be in the form of P by Q, right? So it can be like this, for
Yes, ma'am.
example, 15 by 3, it can be like this, or it can be like 6 upon, let's say 9, it can be, this is also rational number. So in this case, there is actually a common factor between them, right? This is like they both are divisible by 3. So 3 is a common factor between them. Understood?
Yes, ma'am.
So we don't want this kind of number. We actually need co-primes. Let's say 2 by 3. So there is no common factor between them. Right, Arshia? So we don't want this kind of number. So we will not say that A and B are integers, but we will say that A and B are co-primes. Understood? We need this kind of numbers here. Is that clear to everyone?
Yes, ma'am.
So,
Okay. So let under root 2 is rational. Okay. Then there exist co-primes such that we can write that under root 2 is equal to A upon B, right? Co-primes A and B. Sorry, co-primes A and B such that under root 2 is equal to A and B. So we have to assume co-primes, not integers. This term is important. You will see why. Right? Okay. Now just square both sides, right? So under root 2 whole square is equal to A upon B whole square. I'm just squaring both sides. So this becomes 2, right? Okay, is equal to A square divided by B square. So I can write that 2B square is equal to A square. Is that clear?
Yes.
Yes, ma'am.
Okay, now before this, there is a theorem. It's a one-line theorem. So let's write before this thing. I'm just leaving it here. Sixth topic, you can say it's a theorem, right? Please write it down. That let P be a prime number, okay? So underline prime number. It has to be a prime number. And A be any positive integer.
And could you go back?
Just 1 minute. I'll go back to that, but please note down the theorem first of all, because I'm going to use this theorem, right? If P be a prime number and A be any positive integer. Okay. So these are the two assumptions. Now, if P divides A square, then P divides A. That is a theorem, right? Is this understood? So if you have any prime number P, right? And then any other
Yeah.
positive integer you have. So if the square of the integer is divisible by P, then A is also divisible by P. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now I'm going back. So this theorem actually you have to write before that proof. Now I'm going to use it. So I've got 2B square is equal to A square, right? So that means, see, now try to understand that A square is actually 2 into B square. So that means 2 is a factor of A square, isn't it?
Yes, ma'am.
I'm breaking A square into two factor. One factor is 2, other factor is this B square. So that means what I can write here, that implies that 2 divides A square. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yeah. And by the use of that theorem, I can say that 2 divides A. So here I have used that theorem. You can write from theorem, right? So this you can mark as your result number 1 because I'm going to conclude something from here. I hope it is understood by everyone.
Yes,
Yeah.
ma'am.
Right. Now the second part of it. So therefore, now try to understand. Now because 2 divides A, that means 2 is one of the factor of A, right? Okay.
Yes,
Yes,
ma'am.
ma'am.
So therefore, A can be written as 2 into something. So 2 into C I can write for some integer C. Any integer C, right? So if, see here, if 2 divides A, that means 2 is one of the factor of A. So that means A is basically 2 into something. Is that okay?
Yes, ma'am.
Yeah, 2 is one of the factors. So it's 2 into something, and that something you can take any integer. Okay. Now again you do squaring. So I get A square is equal to 4C square. Clear? Now in place of this A square, again you use this result. So in place of A square, you can write 2B square is equal to 4C square. Clear?
Yes, ma'am.
Okay. So just divide by 2. So b square is equal to 2c square, right? Again, what does it imply? That see, again, b square is basically 2 into something here. That means 2 is one of the factor. So that means 2 will divide b square. So we can write that 2 divides b square, right?
Yes, ma'am.
Okay.
Yeah.
And by the theorem, again, I can say that 2 divides b, right? From theorem.
Yes.
Yes,
Okay. So that is your result number 2. So both we have shown, like we have taken A and B, right? So we have shown that 2 is also dividing A, 2 is also dividing B. What does it mean? It means that 2 is a common factor between them.
yes, ma'am.
Yeah.
Yeah, but that is a contradiction because we have assumed them to be co-primes. Co-prime, the definition of co-prime is that there is no common factor between them. And here we are getting a common factor between them, which is 2. Understood? So that is the contradiction. Got it? So here you will write that from 1 and 2, we can conclude from 1 and 2, the result 1 and 2, we can say that 2 is a common factor of A and B. Okay. So this contradicts the fact that A and B are co-primes, right? So there's a contradiction. So this means, after this you will write, this means our assumption is wrong. Is not correct or wrong. So assumption was that under root 2 is rational. Okay, so this is not correct, and therefore under root 2 is irrational. So one of the number will definitely come to prove either under root 2, under root 3, under root 5. These are the same steps in every proof. So this statement is very important. Don't forget to write this thing that they are co-primes, okay? Because this is actually the contradiction in the end. Yes, have you written, Martin?
Yes, ma'am.
Sarah? Alright, I've written. Now homework is prove that under root 3 and under root 5 both are irrational. You have to prove them. Same steps, okay? Same lines, everything is same. Just under root 3 and under root 5. Got it? Now second
Ma'am,
type.
both of them we should do like
Same
separately,
thing.
right?
Yeah, separately.
Yeah.
I mean, first question is prove that under root 3 is irrational. Next question is prove that under root 5 is irrational. Now, there can be second type of question of this type that prove 3 root 2 is irrational, right?
Yeah.
Okay. Now, if the number alone comes, that is under root 2 or under root 3 or under root 5, so the same steps which I have told you, you have to follow that, right? Okay. Now, in this type of question, it actually depends. If it is a 2-mark or 3-mark question, so you don't have to prove under root 2 irrational, first of all, right?
Yes.
Okay, if it is a 4-mark question, then first you have to show that under root 2 is irrational, and then you will show that 3 root 2 is irrational. Got it?
Yes, ma'am.
Okay. Same you will do. Let 3 root 2 is rational. Let us use the method of contradiction here. Okay. Then again, there exist co-primes A and B such that 3 root 2 can be written as A upon B. Is that okay? So we will keep the under root 2, the root on one side and everything on the other side. Okay, that's it. Now you just have to see, now we already know that the LHS is irrational. We don't have to prove it. Okay, now look at the RHS in this case. So right hand side, if you look at the RHS here, so that is A upon 3 into B. Okay, so that means A is what? A is an integer. Okay,
Yes, ma'am.
coprime means there is no common factor, but the numbers are actually integers, right? I can have 2 and 3, although they are coprimes because there is no common factor, but they are integers, isn't it?
Yes, ma'am.
So A is actually an integer divided by, then 3 is again an integer, and multiply B is again an integer, right? So it is integer divided by, and if you multiply an integer by another integer, again you get an integer. You know that, right? For example, you multiply 2 into 3, you will get 6. 6 is again an integer, right? So that is integer upon integer. Is that okay? And what is integer upon integer? I mean, it is rational. Clear? You can say that your
Yes,
RHS
ma'am.
is rational, like P by Q, P and Q both are integers. So your RHS is actually rational here, and we already know that under root 2 is irrational. So this contradicts the fact. So we can write RHS is rational, right? So this contradicts the fact that under root 2 is irrational. See, when I have I'm getting some irrational on this side and I'm putting an equal to sign. What does it mean? Equal to means that the RHS should have to be irrational, isn't it?
Yes, ma'am.
Equal to means your LHS is equal to RHS, right? Exactly equal. It's equal. But here there is a contradiction. LHS is irrational, RHS is rational. So this contradicts the fact that under root 2 is irrational, right? Hence, we can say our assumption is not correct. So there's a problem in our assumption. And therefore we can say that 3 under root 2 is irrational. Clear?
Yes, ma'am.
Okay. Now you have written it. There can be another type, you can say third type, which you can have a plus or minus kind. Prove 5 plus or 5 minus under root 3 is irrational. This kind of number you can have. Or take it minus. Let's take minus. 5 minus under root 3 is irrational. So basically there is a rational number and then addition or subtraction with an irrational number. Now how to do it? Okay, I'm skipping all the lines. You have to repeat the same lines. Okay. Just when you
Yes,
take
ma'am.
that, when you take 5 minus under root 3 is equal to A upon B. Please repeat this line which I am leaving. So you keep the under root 3 on one side, right? So you can write,
Yes.
5 minus of a upon b and take root 3 on the RHS. It becomes plus. So root 3 part we have separated. Now just analyze this, whether it is rational or it is irrational. So look at it. 5, or you can show here. On the side, you can show this thing, that 5 minus a upon b is actually equal to, if you just solve it, take LCM b. So it becomes 5b minus a, right? So this is 5b means integer multiplied by integer. Clear? So you will get an integer. Is that okay? Minus an integer,
Yes.
right? And then divided by an integer. Okay. Now, if you subtract one integer from the other integer, you again get an integer. Clear? For example, you are doing
Yes.
4 minus 3, so you get 1, which is an integer. Or you are doing 3 minus 8, so you get minus of 5, which is again an integer. So you again get integer upon integer, which is of the form of, you can say, p by q. That means it is rational, right?
Yes, ma'am.
Yeah. So we can say again the same thing, repeat the same lines. Okay. This contradicts the fact that under root 3 is irrational. Therefore, our assumption is wrong, and therefore 5 minus under root 3 is irrational. Same lines you have to repeat. Clear?
Yes, ma'am.
Now, fourth type, very
Ma'am,
quickly.
1 minute.
Okay.
Ma'am,
Hmm.
ma'am, that half yearly is on 26th.
26th. Okay, there's time for that, right?
Yeah.
I think we have done enough revision, but rest depends on you. How much do you practice? Okay.
Yes, ma'am.
Yeah, please repeat the questions, solve them yourself. Don't just read them. Okay, okay. You know what students do is they open their notes. Okay, okay, okay. This I can do, this I can do. This. And when they start doing it, they get stuck in the exam. So better you close your notes, try to solve every question yourself. And when you get stuck, then you check in your notes.
Ma'am, done.
Yeah, okay. Now next number can be this, that prove that under root 2 plus under root 5, like both are under root kind of question, is irrational. This can be asked, right? So how will you do this kind of question? Same line, you have to write a and b and all that. So you write under root 2 plus under root 5 is equal to a upon b. Clear? So
Yes, ma'am.
you can keep one number and take the other. You can take minus, you can take under root 2 there, or you can take under root 5 there. There is no issue. So I'm keeping under root 5 here, and I'm taking a upon b minus of under root 2. Clear? Because on one side, I want to keep an irrational number, right? Because I know under root 2 is also irrational, under root 5 also irrational. So I can keep any of the number on LHS, right? Now you square both sides. So under root 5 whole square is equal to a upon b minus under root 2 whole square. Clear? So that becomes 5, okay, is equal to, now this is a minus b whole square. You have to use identity. So that is a square plus b square minus 2ab. Clear? So that becomes a square plus b square, right? And plus b square, that means under root 2 whole square, and minus 2ab. So 2 into under root 2 into a upon b. Clear? So 5 is equal to a square upon b square. This becomes 2, and then minus 2 root 2 a upon b, right? So the only under root I can see here is this under root, right? So I'll take everything on the other side. Clear?
Yes,
Yeah.
ma'am.
Okay. Mm, yeah, so I'll take this like because this is minus, right? So I'm bringing it on the left hand side. So 2 under root 2 a upon b is equal to, and on the right hand side I'm left with a square plus 2, and then I'm taking this 5 there, it will become minus. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. Right. So just simplify a little bit. So 2 under root 2 a upon b is equal to, so here a square upon b square, and this becomes minus of 3, right?
Yes.
So you, how will you do it now? Okay, take LCM first of all on the right hand side. So 2 under root 2 a upon b is equal to, so LCM is b square. This is a square minus 3b square. Clear?
Yes,
So
ma'am.
now you keep only under root 2 here and take everything on the other side. So this b which is in the denominator, it will be multiplied with the numerator, and then this 2a will come here, and b square is already here. Is this clear?
Yes, ma'am.
Okay, so 1b square get cancelled out. Sorry, 1b. So you have a square minus 3b square divided by 2ab. Is this okay?
Yeah.
Okay. So now basically you have to analyze this thing. Now LHS is irrational, you know. Clear? Now look at the RHS. If you look at your RHS now, so A is what? A is an integer. Clear? So integer into integer. Whole square will also be an integer. Is that okay?
Yes, ma'am.
So a square basically, or you can say integer square minus 3 into some integer square, and divided by 2 into there is an integer and multiply by an integer, right? Or 2 is basically again an integer, or you can write 2, no problem. So integer square is again integer minus integer, and then divided by, if you multiply integers together, which obviously there is no 0 here, so again you get an integer, and integer minus integer is again an integer, so there's integer upon integer kind of thing here, which is rational, right?
Yes, ma'am.
Yeah.
Yeah, so again we will say that RHS is rational, and this contradicts the fact that under root 2 is irrational, therefore our assumption is wrong, and therefore under root 2 plus under root 5 is irrational. Same line you have to repeat. So please practice some 1 or 2 more questions on this.
Yes, ma'am.
Okay. Now there's one last last topic which is remaining, which I'll take in the next class, is this eighth, which is basically determining the nature of, you can write the heading, determining the nature of the decimal expansion of rational numbers. Okay. So you have to determine the nature, that what kind of decimal expansion is going to be there. So you are not going to perform the actual division and see the answer, but some other way you have to tell, right?
Yes, ma'am.
Okay. Let's revise a little bit. In your class 9th, did you study about decimal expansion? Does anybody remember anything from class 9? Sar?
No, ma'am.
No. Martin, do you remember something about rational and irrational decimal expansion? Say honestly, it's okay. Okay. Decimal expansion means I'm converting a rational number. Rational number is of the form p by q, right? For example, I can have 5 divided by 3. So basically, I'm not leaving it like this. I'm converting into decimal. So I'm doing 5 divided by 3 and then some answer I'll get. So I get 3 into 1 is 3, then 2, right? So I'll to put 0 here. So I get 2 in 6 is 18, then again 2 and 6 is 18, then again